Right, this is your review for your big quiz. So on the first problem, or first two problems, we need to graph these inequalities. The first one is in slope-intercept form, so we need to identify the slope, which is 2/3, and the y-intercept, which is 0, -5. Before I plot those, though, I need to look and see. This one has a less than, so it's going to have open circles and a dashed line. If it had a greater than, same thing, but like on number 2, if it was less than or equal to or greater than or equal to, solid line. So since this is open circles, I have a point at 0, -5, and then I'm going to go up 2 and right 3 and make a point, or I could have gone down 2 and left 3. Once I have my points, I'm going to connect with a dashed line. Then I need to pick a test point. 0, 0 is not on my line, so I'm going to test it with the point 0, 0. And when I plug that in for x and y, I get 0 is less than -5. That is false. 0, 0 is right here, so that means that's the false side of the line. But I want to shade the true side, so I'm going to have to shade down here. If my statement had been true, then I would have shaded the side where my point was. On number 2, this is in standard form. So in standard form, I have to find the x-intercept, which is when y goes away. So I have 3x equals -24, so x equals -8. And then for the, and that is an ordered pair, would be -8, 0. For the y-intercept, that is when x goes away, so I get -4y equals -24, so y equals 6, so my point is 0, 6. Now this one, because it's less than or equal to, or if it had been greater than or equal to, closed dots and a solid line. So I have a point at -8, 0, and a point at 6, 0, and I'm going to connect the dots. Now I need to test. 0, 0 is not on my line, so I can use it as a test point. So I'm going to plug in 0, 0, and I get 0 is less or equal to -24, which is false. So again, my 0, 0 is on the false side, but I want to shade the true side, so I'm going to shade up here. All right, let's try this again on number 3. Now we have a system of inequalities. On the first equation, that's in standard form. So I have 3x, so I need to find my x-intercept. So my x-intercept is when y goes away. So I get 3x equals 15, so x is 5. So my x-intercept is 5, 0. My y-intercept is when x goes away. So I get 5y equals 15. So y equals 3, so that's 0, 3. It's greater than or equal to, so I'm going to have a solid line and closed dots. So I have 5, 0 and 3, 0. And connect the points. All right, when I test it, I can use 0, 0 because it's not on the line. So I get 0 is greater than 15. That's false, so I need to shade away from the center. Let's see what happens on number 2. Number 2 is in slope-intercept form, so I can just identify the slope as being 1/2 and the y-intercept as being 0, 3. So here's my y-intercept, but now I need to go up 1 and right 2. Oh, but on this one is less than, so it's open circle. So I go up 1, up 2, up 1, right 2. Excuse me, I misspoke. Dash line. Looks like this. All right. When I test this one, I can still use 0, 0 because it's not on my line. So I get 0 is less than 3. That's true. So I'm going to shade towards the center. Last but not least, I have x is less than or equal to 4. When it's x, then it's going to be a vertical line. So I'm going to, whoops, that was not very straight. Let's try this again. So I'm going to have a vertical line at 4. All right, so when I test this one, I can do 0, 0. And so I get 0 is less than or equal to 4. That is true, so I need to shade towards the center. So if I look, I need to go to the right of the blue, below the green, and to the left of the red, which means I'm going to shade right here. And that means, again, that any point in that shaded triangle is going to give me a true statement. All right. Number 4 is a calculator problem. So I need to get my calculator open. For these problems, you need to plug them into your calculator and see what you can get. All right, so I'm going to go to my y equals, And I'm going to clear everything out. On the left side, I'm going to put in x squared plus 5x and then minus 2. Down below, I've got 6 plus, and I need the absolute value, so I go to Math, scroll to the right, absolute value, and in the absolute value, I need 3x plus 1, and I can scroll out. Now, I don't know what the window was previously, so I always want to start with the standard window, so I go zoom 6, and there's my standard 10 by 10. So there's my parabola, and now I can see my absolute value. Well, I know they're going to intersect, but I can't see either one. So I'm going to have to adjust my window. So as I'm looking, I know it's going to get me further. I need to go a little further to the right, but not much. So I need to increase my x positive just a little bit. And I can tell I need to go definitely up. I don't know how much up, so let's figure this out. So I'm going to, with my window, I'm going to do the x maximum as 15. That gives me a little more to the right just to be safe. But for my y maximum, I bet I need to go pretty high up. So I'm going to go 30. Then I feel like I'm safe. Now, once I adjust everything, I can hit graph. Okay, so here's my parabola again. And here comes my absolute value. Okay, well, good news, bad news. Good news is I can now see my intersection on the right. Bad news is I still can't see the one on the left, but I know better how to adjust the window, so I'm not that far off. So let's calculate this one on the right first. So I'm going to do second, calculate. Option 5 is intersection. Go to the intersection, hit enter 1, 2, 3 times. And when I round to the nearest thousands, which is 3 decimal places, I get 2.162. All right, but now I need to find the other point. So to get to that other intersection, I need to go up a little further. I probably don't need to go more left, just need to go up just a little bit more. So going up is your y, so I need to make my y positive bigger. So what if I try making it, whoops, went down too far. What about 35? Because man, it's close. And then hit graph. There's my parabola. And, oh, there we go. We got it. There's my absolute value. And now you can actually see both intersections. All right, so I'm going to do second, calculate. And I want option 5, intersection. So I'm going to move my cursor all the way around. All the way around. Keep going. Oops. That's pretty close. Hit enter 1, 2, 3 times. And my intersection is negative 8.795. So I'm going to go back to my notes. Here is my parabola. And then here is my absolute value. So my 2 points are 2.162 and negative 8.795. All right, let's turn over to the back. We've got a word problem, and I've adjusted a couple of the words on here. All right, so we got a clown, and he earns money for birthday parties and for making appearances, and he needs to make $400 a week. And to keep his clown license, there are certain rules. He must work at most 16 hours a week, and he can do no less than 5 hours of appearances. Okay, so let's see if we can figure this out. We know there's 2 things he can do. The first is he can work the party. So the first is the hours at the party. Okay, and the other thing he can do is the hours making appearances. All right, so now let's see if we can put together some inequalities to make this work. So first, let's talk about the money he's going to make. So if I take $50 for every hour at a party, that's how much money he makes for the party. So I'm going to do 50 times X. And then if I add to that the hours he's at the doing appearances, that would be 25 times those hours. Okay, that's got to be more than, because it's got to be at least 400. So this has got to be bigger or equal to $400. Okay, then to keep his clown license, he must work at most 16 hours. So if I add the hours at the party and the hours at appearances, it has to be these numbers together cannot be more than 16. It can equal 16, but not more than 16. And then Clown Law also states you can do no less than 5 hours of appearances. Well, appearances is Y, and no less than means he's got to do at least 5 appearances. Okay, so this has got to be greater than or equal to 5. All right, now that we have our facts, let's see if we can graph it. So equation 1 is in standard form, so I need to find my x-intercept. That is when y goes away, so I have 50x equals 400. X is going to equal 8, so it's going to be 8, 0. My y-intercept is when x goes away, so I have 25y equals 400. I divide and y equals 16, so that's 0, 16. These are all less than or equal to or greater than or equal to, so it's a closed circle, so point at 8, point at 16, and there's my line. When I do the test and plug in 0, 0, 0 is not greater than 400, so I need to shade away from the center. All right, let's try the next line. The next line is in standard form, so the x-intercept is 16, and the y-intercept, whoops, can't figure out what I'm writing here. The y-intercept is also 16, so I can plot those 2 points and connect the dots. Okay, and now when I do a test on this one, 0 is less than 16. Yeah, absolutely. So I'm going to shade towards the center. So I know it's going to be in between my blue and green lines. And finally, y is greater than or equal to 5. Well, when it's y equals, it's a horizontal line. So here's my horizontal line. And when I test it, I get 0 is greater than or equal to 5. That is false, so I got to shade away from the center. So what I end up shading is this region right here. So that means any point in that region would make this a true statement. So I'm going to pick a point. This one looks good. Okay. And I get 8. Whoa. Just kidding. Okay, the point is 8, 7. Okay. So at 8, 7, we know that 8 is the x, so that's the hours of the party, and y is the appearances. So Gizmo could do 8 hours at the party and 7 with appearances. Now check real fast. You don't check everything, but do some basic checking. 8 and 7 would be 15 hours. Is that less than 16? Yes, and he had to be an appearance at 5 or more, and it's got 7. So that works. So it does logically make sense. All right, we got one last problem, and we're going to use our calculator for it. So Grant has nickels, dimes, and quarters. Oh, we've done it when it's 3. This is the first time. Okay, so let's see if we can figure this out. So first we need to declare our variables. So since nickels is first, I'm going to make x be the number of nickels. Okay, so y is second, so it's going to be the number of dimes. And last but not least, z is going to be the number of quarters. Now, since we have 3 variables, this time we're going to have 3 equations. So let's see if we can figure this out. Altogether, his money is $3.20. So to figure out the value of the money, nickels would be 0.05x plus dimes would be 0.1y plus quarters would be 0.25z. And that would equal $3.20. All right, what else? All the coins together are 22 of them. So if I add the number of nickels plus the number of dimes plus the number of quarters, it will equal 22. But then it also says he has 15 dimes and quarters. So the dimes and quarters add to 15. So y plus z, notice I'm not going to or add X, because we don't have nickels, adds up to 15. Now, yes, we can figure some of these things out now that we know 2 of the 3, because we can do 22 minus 15, that's going to give us X, right? And that's going to get us closer. But I want you to use your calculator on this. The ones that are to do with the actual work, the ones where you're going to solve by elimination, that's only going to have 2 variables, so it's a little bit different. So now I said to solve this, I want you to now make an augmented matrix. Okay, so I'm going to have 0.05, 0.1, 0.25, and then my constant of 3.2. The next would be 1, 1, 1, because there's no number in front of the variable, it's 1, constant 22. And then for the last one, there's no X, so that's 0. The Y is 1. The Z is 1. And this is 15. And I put my 3 dots in between. All right. Now I'm going to use my calculator to solve this system instead of working it out by hand. So I'm going to go to my calculator, get out of the graphing, and now I need to go to my matrix. Okay, so I'm going to hit second matrix. I need to edit it. Okay, I'm going to edit A. Now, if I look at this has got 3, or if you look at your notes, you have 3 rows and 4 columns. So it's 3 by 4. Okay, and if you're not sure, look at it. Does that match what you want? If not, fix it. Okay, and then we got to put our information in. So 0.05 and 0.1. 0.25, and my constant 3.2. And then my next one is 1, 1, 1, 22. And then my next one is 0, 1, 1, and 15. Okay, now that we have it entered, to get out of that, you do second quit. I need to go to matrix again, so second matrix. We want to do math with this matrix, and we want RREF. So I'm going to scroll up to option B and hit enter. Now I need to tell which matrix to use. So I'm going to go back to matrix, and I want A, and hit enter, and enter again. And we know we've done it correctly because we have 1 down the diagonals. So now we know that 7 is our X, and 6 is our Y, and 9 is our Z. So if we go back to our notes, X is the nickel, so the number of nickels would be 7. Y is the dime, so the number of dimes would be 6. And Z is our quarter, so the number of quarters would be 9. And we're done.